All right, our last lecture ended with an introduction to Project Apollo. The first manned missions for the United States were called Mercury. Okay, first Russians were Vostok. Um, the Mercury and the Vostok were mainly just learning to get into space. So they were purely just experimental learning to get into space. With the decision to go to the moon and the realization we need a lunar rendezvous mission, we needed more experience. So that's where Gemini came in. Gemini, we could dock, we could maneuver, we could do long duration experiments. In fact, the other thing is they realized that you have to get out of the spacecraft sometimes on the way to the moon or on the lunar surface, and so you need to test spacesuits. The spacesuits that were used in Mercury were really high altitude suits used by the Air Force for like spy planes or other very high altitude aircraft. The U-2 U-2 aircraft, for example, spy plane was non-pressurized, so you had to wear a high altitude suit, and that's what they were using as a space suit for the Mercury, just in case there was a leak in the capsule and the pressure dropped. It was not really designed to keep the astronaut alive for an extended period in the vacuum of space. It was just a last-ditch sort of thing. So they had to design a spacesuit to do this, and they tested it in the Gemini missions. So the Gemini missions, they actually opened the hatch and they climbed outside, they floated around, and they had a couple scary moments there. For example, one of the astronauts couldn't even get back into the capsule because he was like moving around so much, heating up. It was much more difficult to move in space than they thought, and he was getting overheated, his heart was racing, his visor was covered in sweat and condensation. He couldn't see, and he tried to get back in, and he found out that in the vacuum of space, the spacesuit had puffed up a little bit, and so he didn't fit back in the capsule. And so they were actually at the point of trying to decide if they're going to have to just cut him loose and leave him up there and bring the other astronaut back or not. And so as a last-ditch effort, they decided to shut off the oxygen to his spacesuit, which was actually being fed by a long tube from the capsule, and then have him bleed off a little bit of gas to release the pressure in his suit so it would actually shrink a little bit and he could fit back in the capsule, and that worked. So after that, they had to redesign things so that they didn't have that sort of problem. So that was all in Gemini. But to really go to the moon, we had to have a much bigger rocket, the Saturn rocket. And so here's a graphic showing the capsule that was used to just go into space. That's the Mercury capsule. Slightly bigger capsule here with a service module with additional equipment to stay up there. To go to the moon, we needed an even larger capsule for 3 astronauts in there, together with a service module here. That service module had oxygen tanks and water and electronics and batteries, and then fuel tanks for this engine here that was actually going to push it back to Earth. And then a lander. The lander was the actually compartment inside there was actually quite small, barely big enough for like 2 astronauts to stand in there. No place to really sit down, and then cabinets for equipment, and then fuel tanks and batteries. It would land, and then the bottom part here had fuel tanks and then equipment bays for some of the experiments, and a big engine here to land. When it took off, there was a small engine in there. It left all of this on the surface, and the small engine there would separate, and only that part would go back into space and rendezvous with the mothership, which still had an astronaut in. To get there, they needed a much bigger rocket. So this was the Atlas rocket that put John Glenn into space. That was the Titan missile right here that put the astronauts into orbit for the Gemini missions. And that giant thing on the left over there is a Saturn V. And so the Saturn V is enormous. In fact, the first stage of the Saturn V had somewhere close to like 90 tank cars worth of kerosene and liquid oxygen in it, which it burned in 3 minutes. to lift a 7 million pound spacecraft off the ground. And it burned it in 3 minutes, and that first stage would drop off. Second stage engaged. First stage had 5 engines on it. Second stage would engage, had 5 engines, but the fuel was liquid hydrogen and liquid oxygen. And so that would put it up close to orbit. And then the third stage would ignite. It had one engine with liquid hydrogen and liquid oxygen, and that would fire, put them into orbit, and then fire to push them off towards the moon. So that engine had to actually start and stop in space. They'd never done that before. So that's why they had to test all this in Earth orbit before they actually launched to go to the moon. And then once they went to the moon, they would have also, I forgot, there's also an escape tower here that would yank the capsule off the top of the thing if it exploded. If it exploded, it would blow up with the force of an atomic bomb. So it was always questionable whether the escape tower would really save them or not. But at any rate, that would be jettisoned, and then the command module would separate. It'd have to turn around, stick its nose in, and pull out the lander, and then they'd fly to the moon. So there was a lot that was involved in all of this. They assembled the rockets. Instead of assembling the rockets at the launch site, they actually assembled the rockets in a giant building nearby and carried them to the launch site. Previous rockets, they did the final work at the launch site. Here, these rockets would take so much final work, they didn't want to leave them out in the weather. So the crawler transporter was designed to assemble the rocket on the transporter. It then carry the rocket out to the launch pad like a mobile launch platform. And they would also pick up a tower they could move along next to the rocket to service it and feed umbilicals with fuel and so forth prior to launch. They kept using the crawler transporters after the Apollo missions. The last Apollo mission was 1972, and the crawler transporters were repurposed to carry the space shuttle around. So there's one of them, one of the crawler transporters right there carrying a rocket with its launch tower. And another crawler transporter is actually holding this gantry right here that's going to go over here and do final servicing. Then that would be carried off somewhere before they got ready to launch. To build everything, they built the vehicle assembly building. At the time when they built this building, it was the largest indoor spaced building on Earth. It had 4 high bays right there to assemble these rockets. Up to 4 of them at a time could be operating, could be being assembled. The low bays off to the side over here helped assemble other parts, which then they swung into position in the high bays. Sitting next to it is this little squat building right there. That is the launch control building. So all this was built in Florida adjacent to the Patrick Air Force Base. So rather than using a military site, NASA was building their own civilian site adjacent to it. And so this became the Kennedy Space Center. And so it still is adjacent to the military site. And a couple of the first test flights actually launched from a launch pad at the military site. Here at the Kennedy Space Center are sites 39A and 39B, which launched all the missions that actually went to the moon. And so at the launch control building, that's where the firing room was that launched everything. They actually had more than one firing room there, so they could actually, in principle, be controlling 2 rockets at 2 different launch sites, okay, launch pads, and then practice firing room, so they could go through practice without actually launching anything. And so the windows face out towards the launch pads, but those shutters on there are not just for decoration. They're actually spring-loaded steel shutters that would snap closed in the event that the rocket blew up. And that way the concussion will not blow in all the windows and injure all the people at launch control. But here they are looking towards the launch site, which was about 3 miles away, or 4 miles away. And so that's where the actual launch was going to take place. And so the crawler transporter would carry them from the launch building out, from the assembly building out to there, and then they would launch. not everything went smooth. The on the launch on that town on the launch pad sitting there is actually what's called a Saturn I rocket. The upper stage is the same as the Saturn V. The first stage is like a whole bunch of almost like redstone strapped together to make the first stage. And so this became the first Apollo mission. It was later redesignated Apollo 1. But on board was Ed White, Gus Grissom, and Roger Chaffee. Now remember, Gus Grissom, I had said in one of the missions, the second manned mission, his capsule landed, Mercury capsule landed, the door popped open and it sank along with all the scientific data, and he was rescued. But ever since, they actually had a door that was not easy to open, so it could not just accidentally pop open. And as a result of that, they redesigned the door so that they couldn't pop open it. It had to take a wrench to open it. Well, they were practicing to launch the first manned test of the capsule in Earth orbit. And before you launch, what you do is you actually sit in the actual capsule, not a simulator, but the actual capsule. You do the simulator first, then you just sit in the actual capsule and go through a simulated mission with the launch control in the actual launch room. And you go through all the steps you're going to be going through in the actual capsule, because it's always a tiny bit different than the simulator. And the other thing you do is you pressure test the capsule. So you pump it up to make sure there's no leaks. Now, NASA was being told they were short of money, and so they were not allowed to do the test separately. So what they did was they did the test simultaneously. Put the astronauts in there, go through a extended simulated mission while they've got the pressure above atmospheric pressure, and testing it for leaks. Well, the problem is they use pure oxygen. So rather than just plain atmospheric pressure, it's above atmospheric pressure, which means instead of having just the normal amount of oxygen, you have somewhere about 6 to 7 times the amount of oxygen in the air as normal. And with that amount of oxygen permeating things, stuff that normally doesn't burn will become combustible. And so what happened was the spacecraft was kind of built, low bidder in a hurry. The seats they were sitting in rubbed some of the communication wires, and they were noticing they were static throughout, the communications here. And then all of a sudden there was a spark, and things caught fire. And so 2 of the astronauts tried to open the door, while the third one says, "We got a fire, we got a fire." Pad workers rushed over here to try to get to them, but remember, it was hard to open the door. And so by the time they cracked the door open, blast of hot gases came out and burned the people working there to open the door. But when they finally got the door open, the astronauts were long dead. And so White, Grissom, and Chaffee died as the first casualties of the space program in the United States. And they posthumously renamed the mission Apollo 1, even though it never actually left the ground. And so that's that. It actually almost put an end to the lunar program. They had to redesign the capsule to avoid this problem. They tested several unmanned missions, just launched the capsule on remote control, and then finally in 1968 they launched Apollo 7, which was the first manned mission, which orbited Earth and tested everything out, and they found that not everything was right. They had to redesign a few things. And then they launched Apollo 8 to the moon in late 1968, followed by eventually Apollo 11 to the moon in 1969.